Okay, so this is 12.1 tangent lines, and this is not tangent as in trigonometry tangent. Okay? Yes. It's a tangent to a circle. Okay? So we've dealt with circles, but we have some new lines that relate to circles and the relationships that they create. So the first thing is knowing what a tangent is. So we're going to talk about line AB. AB is tangent to the circle, which means it intersects the circle in exactly 1 point. Okay, and that point, which is called the point of tangency, is B. Okay, so even if you draw a crummy circle and you're looking at your circle thinking, well, it looks like it intersects in more than 1 point, it won't, okay, because every part of a circle is a curve, right? So even my circle looks like it intersects in more than 1 point, but that's just because it's not a perfect circle. So we would say that AB is tangent to circle O at point B. Okay, now what's going to help us use this information to find some angle measures is there's a theorem. There's not a name for it. You just need to know the idea behind it. And it basically says any tangent line is perpendicular to the radius that it intersects. So if we look back at our diagram, tangent AB intersects the radius OB, so that creates right angles at that intersection. Now, the reason we don't really have to be much more specific in the theorem than that is if I drew another radius, it's not going to intersect that same tangent, right? Now, every radius has a tangent line that it intersects, you know, but each tangent only has one radius that it intersects. Okay, so knowing that we have these right angles, what this is going to allow us to do is find some angle measures. All right, so if you have a shape like this, and we'll call this OLMN, and we have some angle measures, the information that we do need to know is we need to know that ML and NM are tangent to circle O. Obviously at points L and N, but we do need to know that they're tangent.
What does tangent mean?
Tangent means they're lines that intersect the circle only at 1 point, and once we know they're tangent, we have this theorem that says the tangent and the radius need to be perpendicular. So using that theorem, then, I would go in and say, okay, well, if they have to be perpendicular, if they're both tangent, I have a right angle here and a right angle there. So that's kind of the new part. The old part is saying, all right, well, if I have a four-sided figure and I know 3 out of the 4 angles, what do I do to find the fourth? What do you know about quadrilaterals and their angle measures? They're not all equal. They do add up to 360 though. I would hope at this point that you would know the triangles are 180, the quadrilaterals are 360. Anything with more sides than that, you could use the angle sum theorem, but those two you should know. So the sum of all angles in quadrilateral is 360. So that means you've basically got x plus 90 plus 90 plus 117 should be 360. So that would be x plus 297 equals 360. So x would be 63 degrees. Okay, so we have another similar type. So another circle. Go ahead and draw a diameter in that one. Okay, so this is the information you would have here. This is not a quadrilateral. But if we said DE is tangent to circle O.
I mean, EDO would be 38 degrees.
No, EDO wouldn't be 38, but it's tangent to the diameter, which makes it tangent to the radius, so it's 90. So you get a right angle there, which leaves us with 2 out of 3 of our angles. And we know from the sum of a triangle that they have to add up to 180. So we're going to do x plus 38 plus 90 equals 180. So x should be 52 degrees.